Hello friends, have you seen Hanuman tail here? Last class we have discussed about this tail. This is connected, this is similar to our lap winding. Okay, so lap winding. So what is the lap winding? The conductor of one coil starts from one slot under one pole, let us north pole, and goes to the slot under the adjacent pole, let us assume the south pole, and return to the slot under the first pole. That means here it is winding starting the north pole is going to the south pole and coming to the north pole and south pole, north pole and south pole, north pole and south pole. So this type of the winding we can say this is a lap winding. Okay, so last class we have elaborated this winding. This is the lap winding you have seen. Okay, so this is started here and it's going, this is a conductor with the back pitch, it's going to the another slot and come back here starting another slot and it's going to this one and coming back and going to the once again this one. Okay, so this is known as the back pitch YB, this is known as the front pitch YF. Okay, here this is a north pole, this is a south pole, north pole and south pole. The coil which is start in the first slot with the back pitch YB, this is the we are going to connect here. It is connected under the this is a south under flow influence of south pole and is going it is over. Now once again it is coming to here and it's going to the north pole and it's going to this one once again it's going to here, this is coming here. Okay, this type of the winding we can say lap winding. Okay, similar to the ear once again starts. Okay, so this is the lap winding we have seen in last class. Okay, what are the salient points? So here these are the different types of armatures used in our electrical field for the different applications. This is a one rotor circuit armature and having the number of poles, having the number of conductors. And this is another armature. It may be different poles, different armature conductors. And this is a different such a way that so these different applications. As we discussed, this is the shaft, this is the armature core, this is the armature slots, this is the armature winding, this is the commutator and commutator, it is a commutator slots, you can see here these are the commutator slots, observe, and how this winding from the slot 1 to it is connected here and back is going to the another slot coming to this one. Okay, so you can see the length of this armature and you can see that's the length of the armature. Different armatures having the different conductor length for the different applications. Okay, these are the practical examples of armatures in our electrical field winding salient points. Okay, so in which the coil lap over each other in lap winding. So what are the salient points of this one? Here the salient points are 1, number of parallel paths, that is equal to number of parallel paths is equal to number of poles. You know what are the number of parallel paths. Okay, so that means if the 4-pole machine, it is a 4-pole machine, it has a 4 number of parallel paths. Last class we discussed it in detail. It has a 4 number of parallel paths connected in parallel and it's connected to the plus and connected to the minus. Okay, at the same time the brushes, carbon brushes or copper brushes, may be equal to the number of poles. Here number of poles is 4, brushes also 4. So here we are going to connect the brushes. So four brushes we are going to place in the parallel paths. Okay, at the same time for winding purpose, so what are the winding we are going to write, that is the lap winding. So generally the lap winding used for the high current purpose. So it has so many parallel paths depend on the number of poles. Each parallel path has an equal voltage generates, and the total current will be so divided equally in each parallel path in case of the motors. Okay, so here for the winding, development of the winding, so we require to remember that. So what is that one? 2 points. One is the back pitch and front pitch. Both are the must be odd number. Okay, so let us assume yb may be, for example, 9, then yf should be, it may be 7 for progressive winding. Okay, progressive winding, and that means here progressive winding means it is starting, so going this one, so this is the winding, progressive winding. For example, if front pitch is equal to 11, that is equal greater than the back pitch, then it is a retrogressive winding. So winding is starting from this one. So just like this one, coming this direction. Okay, so both must be odd and opposite sign and differ by 2 values. So you can see the two values differ or multiple of 2. And second point is the approximately back pitch and front pitch equal to pole pitch. So what is the pole pitch? That is equal total number of conductors by number of poles. Pole pitch, the distance between the two consecutive poles, north pole and south pole, nearly 180 degrees. And third one is the average pitch. Average pitch is equal to, we can write it, yb plus back pitch plus front pitch divided by 2. So that is equal to nearly pole pitch by p. Okay, so next at the fourth point you have to remember the commutator pitch, the distance between the two segments. So commutator pitch plus 1 plus or minus 1, so plus 1 for progressive winding, progressive, and minus 1 for retrogressive winding. Okay, now the resultant pitch, that is equal to yr is equal to yb minus yf. That means suppose this pole is starting here, we can see started here, one coil, this one, next coil, so we are going to connect, so this slot over, so this coil starting and second coil starting, the difference is equal to resultant pitch. Okay, so based on this one we are going to calculate. And sixth point, so whether you know the back progressive winding and retrogressive as per the given, then you are going to calculate back pitch is equal to, so z by p plus 1 and y front pitch is equal to z by p minus 1. Okay, so you remember these two values for the progressive windings. For retrogressive windings, so here yb is equal to z by p minus 1, yf is equal to z by p plus 1. This is a retrogressive winding. This is a progressive winding. Okay, so based on our requirement, so whether you're going to develop progressive winding or retrogressive winding. Okay, so these are the, let us take the one example, good example. Develop a simple lap winding for DC machine having 32 armature conductors and 4 pole machine. Here the total number of conductors is given 32 and number of poles is given 4 pole machine. He is asking develop a simple lap winding. Okay, so we are going to develop this winding. So what is the answer? Let us see. Question. Okay, so this is a question and this is the answer. We are going to develop this winding. Okay, it has a 4 pole machine, north pole, south pole. You can see here. So north pole, south pole, north pole and south pole. So winding, and this is a commutator segments. This is the best position, and this is a ring diagram. This is the answer. This is the question. Let us develop this winding. How we are developed this winding? Okay, let us see in step by step. This is one practical problem for given this armature. Let us, this is a DC machine. In that it is the armature. This is the commutator segments. Okay, so and these are the slots, commutator slots. This is a copper. This is a insulating mica insulation, and these are the laminated core. You can see the laminated core, and in which there is a winding. You can see this winding is placed here, and this is a front. So sorry, so I'm standing here. This is my front and this is my back. Okay, so from this one I am going to winding here is going to the another slot based on the back pitch, and once again it is coming to the based on the front pitch is coming. Okay, you can see the each coil, each slot consists of number of conductors. Okay, so let us develop this winding. So we are going to place the 4 brushes, and thus the conductors, total number of conductors is 32. Okay, Z is equal 32. Okay, but here what is happened? Each coil having the more number of conductors. But in our example, let us assume that each slot having the only this conductors, 2 conductors. Okay, that means total number of slots. So slot 1, slot 2, slot 3, slot 4. So we are going to get the only 16 slots. Each slot having the 2 conductors. Okay, let us also double layer winding. Now, so let us develop this winding step by step, dear students. This is a question is given. Okay, so based on this question, we are going to develop. This is the answer. Let us do in step by step. Development of a simple lap winding. So is given steps for development of the lap winding. Here simple calculations for the pole pitch and back pitch and front pitch. First step you have to follow it. Then prepare the winding table based on the back pitch and front pitch. Next, third step is develop the winding diagram with the help of the winding table, and connect end connections to the commutator segments and place the brushes as per the current directions in the conductors. And finally, made it a ring diagram. These are the 4 steps you have to follow to develop full winding diagram, dear students. Okay, these are the steps. So let us see one animation. Here the conductors are, we taken the 32 conductors. Okay, so you can draw all lines in parallel. Okay, so here, so draw the parallel lines with equal space and equal to the number of conductors, and number them from left to right, and select any slot as a starting point. Generally the top is a odd number and bottom is a even. Select the slot number 1 as a starting point and proceed as per the winding table. That is a step 2. Below parallel lines, draw the commutator segments and number them as a for the given data. Okay, let's do. Here I have drawn the parallel lines with equal space in each slots. So you count it, how many slots? So nearly it is a 16. So it is a 32, no? 16 slots. Okay, blue color and red color. 2 conductors. Let us assume one blue color is the top conductors and bottom is the red is the and bottom conductors in each slot. Okay, each coil sides 2 placed in each slot. Now number the these each all things. So how many conductors? I place the total 32 conductors in 16 slots. Now, so how many poles? Represent the poles. So pole pitch you find it. So total 32 by 4 poles. So we are going to get the nearly 8 conductors under each pole. 4 poles, north pole, south pole, north pole, south pole. So place that poles. So this is the north pole and south pole and north pole and south pole, you can see. So this is the first thing you have to draw, dear students. After that, here your aim is to draw whether this one conductor is connected to, whether you are going to place this conductor for the normal pitch, or you are going to place so under this conductor short pitch, if you are going to place this one under the long pitch. That is depend upon the your calculations, but that is a YB and YF. So this is a YB. Okay, now it is going to the connect ear back, that is the YF. Okay, so for this purpose, first find out that, so as per the simple calculations where here you are going to calculate what is the pole pitch, what is the back pitch, what is the front pitch. Okay, so that purpose, so we have to do some calculations how to find the YB and YF. Let us see. Based on this one, calculate the what is the YB. Okay, so pole pitch is equal to Z by P. Okay, so what is the Z? So 32 slots and P is equal number of poles. 4 ones are 4 8s are. So nearly 8 is the pole pitch. That means each pole influenced by the 8 conductors, 8 slots. Okay, 8 conductors influenced by the each pole. Now based on the pole pitch, now we are going to calculate the what is the YB. So we know that progressive winding, we are assumed as a progressive winding. Then so progress YB is equal Z by P plus 1. Okay, so that's what is the Z. So 32 by P is equal 4 poles plus 1. So that is a 8 plus 1, that is equal 9. So this is a YB. Then back pitch is equal to 9. Okay, so we know that front pitch we required. So back pitch, okay, minus YF front pitch divided by the 2 or multiple of 2 based on this equation, or you can calculate YF. You know this value, you know that's constant, you are going to get the YF, or you can write it YF is equal to, so same Z by P minus 1, that is equal to 8 minus 1. Okay, then we are going to get the, what is the value? 7. That means here the front pitch is equal to, we are going to the 7. Okay, so dear students, so what is given? Z is equal 32, P is equal 4 poles, and find the pole pitch. That is a simple substitute the equation Z by P plus 1, 32 by 4 plus 1, we are going to get the, this is the 9. So differ by 2, it may be 11 or it may be 7. So here the YF is less than the YB, then we are going to get the 7. So if you know the YB is equal to 9 and YF is equal to 7. So based on this one, I am going to develop the one table, winding table. Okay, so how to create that winding table? Simple. That means here the one first serial number and YB back pitch, and this is a YF. You take it. Here take the serial number 1. So let us start the conductors 1 from the any, you can take the slot, any slot, take as the first slot. In that one we take the one conductor. So already we drawn the these conductors in parallel each other and started from the one conductor, taken this one, and where we are going to connect here. So that is equal to YB is equal to 9, YF is equal to 7. Okay, so then 1 plus 9, so that we are going to connect the 10th conductor. So here 10th, where the 10th conductor here represented, you connect it here. Now 10th conductor minus front pitch 7, that is equal to 3. Now once again this you have to, from this one you are going to connect, where is a 3, so you have to connect here. Okay, now that's first step. Second step, now so 3 plus 9, next this is the third conductor, once again it is going to connect another slot, that is equal to, what is the value? 3 plus 9 is a 12. Okay, now 12th conductor you connect it, you are going to 12th conductor. Now it has to connect which conductor? So that purpose 12 minus 7, you are going to get it the 5th conductor, then you connect to the 5th conductor. Okay, similarly third, 5 plus 9, so you are going to connect the 14. Okay, it should be connected to the 14th slot here. Okay, now once again it has to connect to the which slot? 14 minus 7, that is equal 7th conductor. You connect the 7th conductor here. Okay, once again it has to connect to this one. So here the 4th, 7 plus 9, so that is equal to, we are going to get it 16. Okay, so 6, it has to go to the 16th slot, 16th conductor. Now it is connected 16th. Now the 16 minus 7, that is equal to, you are going to the 9, so it should be come and connect to the 9th slot, such a way that, so here you can observe, dear students. Okay, you can observe here what you are going to observe here. So dear students, don't confuse. Here in the back pitch, it is started conductor 1 connected to the conductor 10. After 10, it is connected to the, once again, 3 conductor. Okay, from the 3, it is connected to the 12th conductor. From 12th conductor to, it is connected to the 5th conductor, and it is connected to the 5th conductor to 14th conductor. So similarly, so you are going to develop the table. In table, you remember one thing, dear students. Here the back pitch values, you can see all values are 10, 12, 14, 16, 18, 20. These are the all even numbers. You can see these are the even numbers. Even numbers. Whereas you can see 3, 5, 7, 9 sequentially differ by the 2 values. So that is equal 11, 13 exactly. So we are going to get the odd numbers. So each differ by the 2. So You have to remember that. So if the sequence is same, your winding table is good. Otherwise, you may in wrong way. Okay, so develop this winding continuously. Okay, so let us complete this diagram now. So this is a one animation for revision. You can see in this case what we have seen, I am drawn the all conductors in parallel each other, and I placed all number values, top one and bottom one, odd and even. So to know the conductor numbers arbitrarily placed the 1 2 3 4 5 up to 32 slots. Now each slot, each 8 conductors under influence of north pole and south pole, so I represented. At the same time, we know that the current direction in north pole, the conductors one direction, and under influence of south pole, the current in the conductor is the another direction. Such a way I represented. You can see here. Let us assume here under north pole, the current is coming from top to bottom, whereas in south pole, let us assume the current is reversed to the north pole, that's from bottom to top. Such a way I represented. Then I know the current directions in each conductors. Okay, so to connect the conductors, I place these conductors. So I have to connect the back pitch and front pitch. That purpose I require the table. How to draw the table? Now we have seen. We are going to complete the table. So based on our table, I am going to connect one conductor to the 9 conductors, 9 to the third conductor, third to the 12th conductor, 12th to 5th conductor. Such a way I am going to just connect these based on the table. So first is connected to the 10th conductor. This is the 10th conductor. Now it is coming here and it should be connected to the third conductors. So just we have developed the table, and third conductor is connected to the and 12th conductors. Just you can see. So that's why I represented all odd conductors, the blue colors, and all red colors are the even numbers. Okay, so here you connected this one. Now after 13th, so you are going to connect to the 12th conductor. This is a red conductor, and 12th is connected to the once again and 5th conductors. Just simple. So 5th conductor, and 5th is connected to the 14th conductor. You can see this is a 13. This is a, where is the 14th? This is the 14th. You can see this is the 14th conductor, and 14th conductor is connected to once again 7th conductor. You can see this is a 7th. Blue is the 7th, and the 7 is connected. Such way that is a simple winding, dear students. Okay, 7th conductor, and 7 is connected to 16th conductor. Where is this one? This is the 15th. This is the 16th conductor, and the 16th conductor once again back to 9th conductor. So you can see. So this is the blue is the 9th conductor. You can connect it to the 9th conductor, and this 9th conductor once again connected to. So 9th connector connected to the and 18th conductor. So this is the 17th. This is the 18th, and 18th conductor is connected to. So here 11th conductor back to 11th. So where is the 11th? This is the blue is the 11th. Okay, 11 is connected to such a way that 11 is connected to 20th conductor. So you can see serially we are going to add it. Simple. So every conductor here you can see serially, there is no missing. Okay, this is connection, end connections and front connections based on the winding table. Okay, so winding table how to draw? So already we have seen. If you know the winding table, simple connections is very easy. Okay, so let us complete that winding table, dear students. Now this is a winding table. Draw this table. Now draw the winding table. So first we take in the first conductor is starting. Okay, so where it is connected to the first conductor, and YB is added the 9, and YF is equal to here The YF is equal to how much? 7 only. Okay, 7. Okay, so 10th 1 plus 9, that is the 10th. Now 10 minus 7 is the front pitch, is the third conductor. Okay, next, so 3 plus 9 is the 12th conductor, 12 minus 7 is the 5th conductor. Next, and 5 plus 9 14, the 14 minus 7 7th conductor. 7 plus 9 16th back pitch, and front pitch you have to come to the front. So 16 minus 7, that is equal to 9. Now 9 plus 9 is equal to 18, and 18 minus 7 is equal to 11, such a way that I am going to develop this table. Okay, so complete all conductors, dear students. Okay, so these are the table, simple table. Okay, so prepare this winding table. This you can say this is a winding table. Okay, once you draw the winding table, so I am going to connect the conductors for physical connections. So if without any pole pitch, so first conductor and 10th conductor, 10 to 3, 3 to 12, 12 to 5. So you can see here one simple ring diagram. You can see this is a first is connected to the 10th, 10th is connected to the 3, 3 is connected to the 12, 12 is connected to the 5, 5 is connected to the 14, 14 is connected to the 7, 7 is connected. You can see here the table. So as per I am going to connect this, but these conductors are zigzag. So as per the table, these are the winding series connection. Okay, so now 22 is connected to the 15, and 15 is connected to 24, 24 is connected to 17, 17 is connected to the 26, 26 is connected to the 19, 19 is connected to the 28, 28 is connected to the 21, 21 is connected to the 30, 30 is connected to the 23, and 23 is connected to 32, 32 is connected to 25, and 25 is connected to the 34 here. So instead of we have the only 32 slots, 32 conductors, but it is coming to 34. So 34 is represented by 2, because 34 minus 32, we have the only 32 conductors, but 25 plus 7 9. Dear students, you can see here one twisting point, you can observe here this twisting points here. Okay, so here 29 plus 25 plus 9 is the 34, but we have the only 32 slots, but it is coming to the 34, so out of range. So what is the difference? So 32, the 34 minus 32 is the 2. So instead of, you can represent the second conductor, you connect that back to the second conductor. Okay, then so take the year 34 minus 7, so 27, we have the 27th conductor. 27th labeled conductor is available, whereas the 34 labeled conductor is not available. That is equal to the second, we assume it 34 is nothing but second conductor. Okay, after 27 plus 9, once again you can see here. So we are going to connect to the 36. There is no 36 labeled conductor. So just you subtract the 32, we are going to get the fourth. So that equal to the fourth labeled conductor. Here you can see here fourth conductor. Now next 36 minus 7, that's a 29. 29 labeled conductor is available. No problem. Next 29 plus 9, so 38. There is no 38 labeled conductor. Similarly, so 38 minus 32, we are going to get the sixth conductor. You connect to the sixth labeled conductor. Okay. Now 38 minus 7 is a 31 conductor. 31 is available. Now 31 plus 9 is the 40. There is no 40 labeled conductor. So 32 minus 40, we are going to get the eighth labeled conductor. You connect the instead of 40. Now 8 minus 7, we are going to get the first conductor. That is the once again come to the starting. That means it is a starting first conductor, ending first conductor. So that's why. So in case of DC, we are going to get it the closed winding. Okay, this is the beauty of the DC winding, dear students. Okay, so don't confuse. Simple, develop the winding table, and so here is for the clarification purpose, I have drawn so one ring diagram how the conductors is connected. So afterwards I will going to place this ring diagram with the commutator segments and brushes also. That is our aim, one of the aim also. Okay, so this clear, I think. Now, so let us develop the winding. Pole, south pole, north pole, south pole. We have the, so this conductors select in color. So all conductors are placed in the armature core. Okay, now so first I will take the first conductor. The first conductor, the back pitch based on the, what is the back pitch? It has to connect to the ninth conductor. Okay, so 1 plus 9, that is the 10th conductor, I am going to connect it. Okay, so then I will connect the 10th conductor. So now 10th, it has to connect in the under north pole with a number 3. So I can connect the 3 conductors. Okay, so blue 1, 3, 5, 7 blue conductors all. So represented is the blue color in the odd numbers and even numbers are 4. Okay, red colors. Now 1, 3 I connect the first one conductor and third conductors connected here. Now 3 conductors we have to go back to the where we are going to connect 12th conductor. We can see the 12th conductor. Okay, now the 12th conductor once again it has to connect to the front. So which conductor? We are going to connect the 5th conductor. Okay, the 5th conductor has to connect the back pitch, the 14th. Okay, now 14th is connected to the 7th. You can see the 7th conductor is completed. Now 7th back pitch connected to the 16th. 16th is connected to the 9th. 9th is connected to the 18th. Okay, 18th is connected to the 11th. And 11th is connected to the 20th. This is a repetitive work, dear students. Very easy. So you have the dropped, okay, you have the pencil. So simple, draw it very neatly. Okay, so as per winding table, simple connect the back pitch and front pitch with neatly. Okay, so this is the, now is a 20 is connected to the front. So connect to the 13th. 13th is connected to the 22. 22 connected to the 15th. So 15th is connected to the 24. 24 is connected to the 17th. And 17th is connected to the, similarly, so 26th. And 26th is connected to the 19th. 19th is connected to the 28. 28 is connected to the 21. Okay, 21 is connected to the 30. And 30 is connected to the 23. 23 is connected to the 32. So total conductor is over here, dear students. Remember here, 32 minus 7, we are going to connect to the 25. Now 25 has to connect to the 34 conductor, but there is no 34 conductor. What to do? So instead of 34 conductors, so I am represented that is the second conductor. So you connect to the second conductor. So here you remember, dear students, it should be goes to the second conductor. Where is the second conductor? Here is the second conductor. That is a twisting point you have to remember. Okay, so second conductor here is, now you can see it. So I connected the second conductor. Now second has to connect to the, which one? 34, that is 27. So where is the 27 here? So you can see it's a 26, this is a 27, you can see here 27. Okay, now you are going to connect to 27. 27 connected. Now 27 is connected to the 36. There is no 36. So that's why I represented as a fourth conductor. Where is the fourth? Here is the fourth conductor. Okay, now the fourth is connected to the fourth and is connected to the 29th. Yes, here this side I have the 29th conductor. Now 29th plus 9 is a 38. So that there is no 38 label conductors. 38 means 32 minus 38. I am going to 6th. The 6th conductor is available. You connect the 6th conductor. That's why I represent 6. Now you connect the 6th here. Okay, 6 conductors over. That 6 conductor should be connected to the 31 conductor. So I have the 31 conductor, blue. Yes, the 31 is connected to the 40th conductor. There is no 40th, that is the 32 minus 40. We are going to get the 8th labeled conductor. It connected to the front is the 38th conductor. Okay, so 8 minus 7. So once again I am going to connect the first conductor. So this is a total winding diagram. Now you can see here, so we completed total winding diagram based on the winding table. Now represent this one. So where is this connections, end connections, no? So these end connections, all these connections connect to the commutator segments. We have the 16th commutator segments. You connect these all segments, each coil connector. So 2, you can see this is a 1, this 2, 3, 4, 5, 6. So this current is coming, this current is, you can see here and here. So here, so all are connected commutator segments 1, 2, 3, 4 up to 16th. Okay, so after connecting this one, you can see where the two current directions are same, represent, that is a plus or minus based on your assumption. Okay, let us do now. So you connect this one, place the all commutator segments connect to the end coils. Okay, so now slots are started 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It is that side or this side. So 16th is connected to the 6, this one, that side or this one, no problem. Okay, we have the 16 slots. Now based on the current directions, where you are going to place the brushes, you can observe, dear friends. Here the conductor 1, see here, the conductor, the slot 1, it is connected to the here conductor 1 and connected to here. So current direction is coming here, current direction is coming here. So we just keep the one brush here, so represent as a plus. Okay, now you can see the here also where the 5th conductor, the current direction is going and current direction is going, then it represent as a negative, such a way that represent the what are the conductors. You can see the 9th conductor. So in 9th conductor, so the current is coming downwards and this is connected, the 24th conductor is coming downwards, then it is taken as a plus conductors. Now similarly, the here you can see the number conductors are 25. So 13th slots, I think. Okay, 13th cemetery segments. So the current is coming here, so it is going the away, here going to the away, that take it as a negative. Now you connect these at the positive brush, this is the positive brush, connect the all positives 1. So here 1, this is the total positive, and this is a negative, and this is also negative, this is the negative. We know the positive and negative, you can connect outside the terminals. Okay, this is a total complete winding diagram with commutator segments with brushes. You can see the animation once again. Okay, so the only slots are 16 only. Okay, now so you can see the current directions. I place the 1 and 9 is the current collecting commutator segments, where I place the brushes plus, and I connect the 5th and 13th is the another place where I place the carbon brushes, this is minus. So this is the total winding diagram. Okay, so I think you can understood very well. Now after completion of this one, your aim is to draw a ring diagram. Okay, so let us do that ring diagram. So this is a ring diagram, dear students. Same what we have seen, the conductor 1 is connected to the conductor 10, 10 is connected to 3, 3 is connected to 12. So we have seen this one. So based on the slots commutator segments here. Okay, so similarly, so whatever the current direction is the same, you can see the current direction is same here, and the current direction is same here, and current direction is the same here, current direction is the same. So where the current directions are same in one slot, place at that our brushes. Okay, so this is the total winding diagram developed in a 32 conductors 4 pole DC machine, dear students. Okay, so now I think you have some idea total winding diagram. Okay, so these are the given problem, and based on the problem we calculated the simple calculations, back pitch and front pitch, and we prepared winding table, we prepared winding diagram, we prepared ring diagram. Okay, so dear students, these are the methods to develop any winding, whether it is a single layer or double layer. Single layer, each slot having the only one conductor side, and a double layer, so it may be consist of the two coil sides. Okay, just here represent the top coil is represented with the solid lines, and bottom coil side is represented with the dotted lines. So after completion of a winding diagram, and find the directions in conductors, current directions. Based on the current directions, you place the brushes. Okay, so this is total lap winding diagram development, dear students. Okay, so thank you for listening my class.